Let's talk about the transformations which result in reflections. So if you take f and you apply a negative sign on the outside, then this will result in a reflection. And now remember that piece of advice that I said. Any changes that happen on the outside of the parentheses are going to affect the graph of the function vertically. So this is going to be a vertical reflection, and it'll be about the x-axis. Now when you have the negative sign on the inside, that will be also a reflection, but it'll be a horizontal reflection. And the horizontal reflection will be about the y-axis. In order to do these transformations, in the first case here, to do a reflection about the x-axis, you multiply all the y values by -1. And in order to do the second transformation, the reflection about the y-axis, you multiply all the x values by -1. So previously with shifts, we were taking all of the y values and we were adding and subtracting something, or we were taking all the x values and adding and subtracting something. In this case, when we have reflections, we're taking all of the x values or y values and multiplying them by -1. Let's do an example. Let's suppose that f of x is the square root of x. So we have one of our toolkit functions here. And what we're going to do is we're going to graph f of minus x and negative f of x. Now, in order to do this, the first thing that you have to be able to do is sketch the toolkit function. Now, a nice way to sketch the square root function is to pick x values which are called perfect squares. That is x values which are the square of some integer. So for example, 2 is not the square of any integer, but 4 is, because 4 is 2 squared. So I'm going to pick x values which are like 4, not like 2. So 0 is a perfect square because 0 is equal to 0 squared. So I'll plot that one, 0, 0. 1 is a perfect square because 1 is 1 squared. Square root of 1 is 1. And the next x value I'll choose is 4. 4 is a perfect square because it's 2 squared. And if x is equal to 4, then the square root of 4, that's 2. So the y value would be 2. And I've run out of room, so let's go ahead and erase this scratch work. The next x value that I'll use is x equals 9, because 9 is 3 squared. So if you take the square root of not 3, but 9, you get 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We need a y value of 3. Okay, so first thing you got to do is sketch your toolkit function. Then after that, we'll go ahead and apply the transformations to my toolkit function. I suppose I should probably connect with a line. There we go. So now I want to graph f of negative x. So I look at that and I say, okay, what type of transformation is it? It's a reflection, and it's a horizontal reflection. Remember, inside the parentheses means horizontal. So I'm going to be reflecting about the y-axis, and I'm going to be multiplying all the x values by -1. So 0, 0, that will stay the same because the x value is 0, and 0 times -1 is 0. At 1, 1, the x value will become -1. At 4, 2, the x value will become -4, and I'm not going to be able to fit this last point 9, 3, but if I could, I would just take the point 9, 3, multiply 9 by -1, and put it on the graph. But I don't have enough room, so I'm just going to include these points. And again, I'm going to connect these points with the curve that resembles the original function. Let's go ahead and label that. That's f of minus x. And now to graph negative f of x, I'm going to do something very similar. I'm going to multiply, instead of the x values, I'm going to multiply the y values by -1. So at 0, 0, again, we stay in the same spot. 1, 1, the y value of 1 will become -1. At 4, 2, the y value of 2 will become -2. And at 9, 3, I can fit this on my graph here. The y value of 3 will become -3. And then I can go ahead and connect these with the curve that resembles the original curve.